Hi students, MCQ number 12. A man sitting on a swing which is moving to an angle of 60 degree from the vertical is blowing a whistle which has a frequency of 2 kilohertz. A sound detector which detects the whistle sound is kept in front of the swing. The maximum frequency of the sound detector detected has to be determined. So this type of question is very important for competitive exams. So it has been asked in the previous year entrance IIT and NEET exams also. This problem is based on Doppler effect. Now let us understand the situation now. So O is a fixed point from which a swing is suspended and a whistle is fixed at position A. Okay, and the length OA is given as L, that is equal to 2 meter. So first I will write L is equal to 2 meter. And the frequency of the source is given as 2 kilohertz, that is equal to 2000 hertz. This is the actual frequency of the whistle. So the position of the whistle is at a distance of 2 meter from the suspension point. So L is equal to 2 meter. Now when the swing is oscillating, what is going to happen to the whistle? The whistle also is oscillating along with the swing. So you can see the next position of the whistle at B. So this is the extreme position of the whistle. With respect to the horizontal level A, at A, now the horizontal level at B has raised by a height h. Is it not? It has raised by height h. So now the potential energy of this whistle at point B must be equal to the kinetic energy of the whistle at the position A by law of conservation of energy. That is the concept I am going to use, from which I can calculate the value of the height h. Before that, you look at the triangle OBC. In the triangle OBC, okay, in triangle OBC, what is cos of this angle? Cos of 60. Let us find out. Cos 60 is equal to adjacent side OC. So adjacent side OC divided by OB. Okay. So divided by OB. The hypotenuse is OB. But the length OB is also equal to what? OA, is it not? Length OB is also equal to OA. So it is equal to the length of the string. So this is equal to OC divided by OA. So once again, OA is equal to L. So this is equal to OC divided by L. Therefore, the length OC is equal to L into cos of 60. L into cos of 60. So first I have found this length OC. Now what is OC? OC is also equal to what? The total length OA minus AC, is it not? So OC is also equal to the total length OA minus AC, which is once again equal to OA minus H. OA minus H, is it not? So I can write now H is equal to, therefore this height H is now equal to OA minus OC. Or I can write this height H is equal to OA is equal to what? L. So this is L minus OC is equal to what? L cos 60. So minus L into cos of 60. So this is H is now equal to L into 1 bracket I have taken. So common factor L into 1 minus cos of 60. Cos 60 is also equal to sin 30, that is equal to what? 1 by 2. So H is equal to L into 1 minus 1 by 2, that is equal to L by 2. So H is therefore H is equal to now L by 2. So I am expressing this height h in terms of what is the length L. So h is equal to L by 2 I have got. Now the kinetic energy at A must be equal to the potential energy at B. So kinetic energy at A, this must be equal to potential energy at B. So half mv square is equal to mgh. This is also equal to mgl divided by 2. So that now this m term can be cancelled. M can be cancelled. So what is V square? V square is equal to 2 into G into L by 2. So V square is now equal to 2 into G into L divided by 2. So that this 2 and 2 get cancelled. So this is equal to G into L. So I can roughly take this value G equal to 10 meter per second square into the value of L is also given. So into 2. So V square is equal to what? 20. Therefore V is equal to square root of 20 meter per second. So this is one of the very important informations. So here V represents what? The velocity of the whistle. So this is the velocity of the whistle, which is the source of sound. Therefore this is velocity of a source. And we write this as velocity of source as Vs. So understanding this is very, very important, students. Are you all understanding first where we started? We want to get an expression for this height up to which to which the whistle is going up. Then we equated from law of conservation of energy, so that with what velocity the whistle is approaching the point A. So when the whistle is coming down from B to A, it is coming with the maximum velocity. So this gives you the maximum velocity. So this is the maximum velocity at the point A. So this is nothing but V maximum also. I can express as V maximum. So this is a detector. So here is a detector which is observing the frequency of sound. So whenever the sound source is at a far off point, the detector will record less frequency. Whenever the source or the whistle is approaching towards A, the detector will record the maximum frequency due to Doppler effect. That is what we have to determine. So then by law of conservation of energy, we equated the kinetic energy at A and with the potential energy at B, so that we got an expression for H. Then we substituted for H and got an expression for V square. Then taking square root, we have got as a V. Now only we are going to apply the Doppler effect. So the apparent frequency, okay. So from Doppler effect, the apparent frequency can be taken as F dash. F dash I will take, okay. So this is equal to the actual frequency F. The actual frequency is given. So apparent frequency F dash is equal to actual frequency into V, the velocity of sound, divided by V minus V source. This is the expression, okay. So when the source means whistle is approaching the observer, that is the detector. This is the expression we have to use. So velocity of the sound, V is the velocity of sound in air. If value is not given, means standard value 332 we have to take. So we will use the calculator to find the calculation, understand that. So this is now equal to F is what? 2000 into velocity of sound is taken as 332 divided by 332 minus the velocity of the source is square root of 20. So using the calculator now I will find out the value. So square root of 20 I will substitute here. So F dash is equal to 2000 into 332 divided by Square root of 20 we will find out first. So square root of 20 is 4.47. So this is 332 minus 4.47. So now 332 into 2000 is 664. So this is 664 into 1000. Okay. 1000 divided by this difference we will find out. So 332 minus 4.47. So this is coming as 327.53. So 664 divided by 327.53. So this is coming as 2.027 into 1000, and the unit is hertz. So the final answer must be what? Therefore f dash, okay, f dash must be equal to 2.027 kilohertz. So this is the answer which we have got. Now the option A itself is exactly correct, is it not? Therefore, option A is the correct answer. So what is the answer we have got is f dash, the apparent frequency is 2.027 kilohertz. So once again, my dear students, I am repeating, such problems will be very tough only for the first time. But when you do similar problems by taking for different angles, okay, for different lengths and all, then you will definitely practice this well and you will be thorough with this. So what is the idea I have to use? What idea we used here? Okay, first in the triangle, okay, right angle triangle, we found the cos of 60 and then found this length OC. Okay, then the remaining height is equal to what? OA minus OC. We substituted and again we involved the law of conservation of energy. What for? To find the velocity with which the vessel is approaching towards the mean position. That is the maximum velocity. Then afterwards we are using the Doppler's effect. Doppler effect formula you should be very thorough. In this case, the detector is the observer. Detector is the observer which is at rest. Okay. And the source is moving towards the observer. So this formula. Suppose if the source is moving away from the observer, then here instead of V minus Vs, we have to use V plus Vs. So several cases are there in Doppler effect. If you are thorough, means such problems will be definitely successfully done by you. I hope you must have understood well. Fine.